Hello and thanks for watching Best Math Tutors. I'm continuing to go through our series of live streams. We're going to cover tree diagrams this week. Tree diagrams are a way of calculating probability, and usually they're used when we've got something where there's two or more possible outcomes. So, for example, removing counters from a bag. So we might have different colours of counters from a bag, and we might need to work out the probability of getting, say, green counters if we had a bag full of green counters. And what we have in these tree diagrams is things called independent events and also mutually exclusive events. So if I'm talking about where it is on the GCSE syllabus, it's around a grade 5, and so that would mean it's on both the foundation tier paper and also higher tier paper. So it's very worthwhile looking at, and it comes up extremely regularly as a GCSE topic. So if we start off by looking at a question, so we've got this one where we've got a tree diagram partially drawn, and it represents someone going to an arcade where they're having a go on two different games. So we've got what's a teddy grabber and a penny drop. So it says the probability that we can win on a teddy grabber is 0.2, and the probability that we can win on the penny drop is 0.3. So we've got a complete tree diagram. So the first thing that we can do is try and fill in this value, and it's very important to know that at a branch, at any branch here, so we can see from this point here, we've got two possibilities. We can either win on the teddy grabber or lose, and we've got at this branch, all the probabilities will add up to make 1. So we've got 0.2, and this probability here must add to make 1 at a branch. So we can see here, we've got 0.2, and whatever value this is at this branch must add to make 1. So we can see that if this was 0.8, then 0.2 plus 0.8 would equal 1. So actually, that's why that's 0.8, because they do add up to make 1. And then if we move on to the penny drop, so also just explain this tree diagram. Up to this point here, what we're doing is we're talking about the teddy grabber. So from the beginning to there, that's only representing what happens on the teddy grabber. And then, since there's two possibilities of what might happen on teddy grabber, we could win or lose, then we take the next event from, if we win on the teddy grabber, well, we're now looking at what happens on the penny drop here, from here, here. And there's two possible outcomes. So we could either win or lose on the penny drop. So if, again, we're using the idea that the branches must add up to make 1, then we've got 0.3 there. So whatever's here must make this branch add up to make 1. So that's got to be 0.7, because 0.3 plus 0.7 must make 1. 0.3 plus 0.7 equals 1 again. So at that branch. And we've got the same thing that's going to happen here at this branch. This is representing losing now on the teddy grabber, and then whatever happens on the penny drop. So since what happens on the teddy grabber doesn't actually affect what happens on the penny drop, so in other words, what they are is independent events. And what that means is that whatever happens on the teddy grabber, so win or lose, won't affect what happens on the penny drop. So they're independent events for that reason. In which case, the probabilities here are going to be the same as they were above. So that's going to be a 0.3, and that's going to be a 0.7, because whether or not he's won on the teddy grabber doesn't affect the probability of him winning on the penny drop. So now we've finished filling in the tree diagram, I've actually got a question on it. So we've got to work out probability that James wins on the teddy grabber and he also wins on the penny drop. So that would represent going along a particular branch. So that would mean winning on the teddy grabber means going this route here. And then when we get to this, we've got a choice again, and we could win or lose. Well, it says we're going to win on the penny drop as well. So that means we're going up this way. And one way we can nicely represent that is to show it like this. We can say the probability, I've represented it as a P, and then inside there we can put in the things, the events that's going to occur. So I'm going to probability of winning on the teddy grabber. So I'll put that as a win, and then T for teddy grabber, and winning on the penny drop. I'll put that like that, P for penny drop. When we've got independent events, like we described this, then we can actually say that that's going to be equal to probability of winning on the teddy grabber, and the and turns into a multiply. So when it's independent events and we want to know that of probability of two things happening in order, then the and turns into a multiply. It becomes the probability of winning on the penny drop. So we're doing probability of winning on the teddy grabber multiplied by the probability of winning on the penny drop. And because we've worked that out, we can say, well, probability of winning on the teddy grabber is 0.2, and we're going to multiply that by probability of winning on the penny drop, which is 0.3. So we could either do that on the calculator. So let me just do that actually. So 0.2, oops, that's not 0.2, 0.2 times by 0.3. If it was on the calculator paper, we'd do it this way, just make sure we don't make any mistakes. And we get that in that form, and we can just press the SD button there, and it will convert it into a decimal then. So 0.06. So we've completed that one. I'm now going to look at another question. So this is a very common sort of question we often get asked about bags containing different coloured balls or counters. So we can see in this case we've got two bags. We've got the first bag contains 4 red balls and 6 green balls. And I might actually sort of roughly represent this. So there's our bag, and I've got 4 red and I've got 6 green in that. So from that, we need to know what would the probability be of picking a red counter. So the probability is that it's 4, because there's 4 red counters, out of the total number of counters in the bag. So what we need to do is we need to add the 4 and the 6 together to get 10. That's 4 tenths. And the probability of going down this route, down the green, is given by the number of green counters, so this time it's 6, out of the total number of counters, so 6 out of 10. And we can also see, we notice that we said before that the branches must add up to make 1, then we can see that the 4 tenths plus the 6 tenths makes 10 tenths, which is 1. We could, if we wanted, actually simplify these fractions. So 4 tenths is 2 fifths, and by simplifying by cancelling the 4 by 2 and the 10 by 2, give us that. And if I do the same thing here, divide top and bottom by 2, and what I'll end up with is 3 fifths. Now I'm going to look at the second bag. So we've got, in this one, 3 red and 5 green. So let me just draw this here. So we've got 3 red, 5 green. And so we need to write down the probabilities on here. So probability of getting a red from that, the number of reds, divided by the total number of counters in the bag. That's 3. That's 3/8 there. And so similarly, we need to, for the green, say how many greens have we got? Well, it's 5, and that's again out of 8. And because we're still in the same condition, so whatever happened to the first bag doesn't affect the second bag. So we can say again we've got 3 reds and 5 greens. Then that's going to be 3/8, and the bottom one is going to be 5/8. So what we've been asked to do in this question is work out the probability that the green that we take 2 green balls from the bag. Okay, so I think that's supposed to say Rachel there, that Rachel takes 2 green balls. Okay, so to do that, for Rachel to take 2 green, that would mean we've got a path to follow through this tree diagram. So we'd have to go this way, and we'd have to go this way. So green plus green. And so we try and write that down. So we're looking for probability gets a green, I'm just going to write it as 1, and then a second green on the second bag. So it's quite useful to write it down using this notation because it saves a lot of writing. So instead of writing the probability that you've got a green is this, it's much easier to just write P and then a bracket for what you're saying is happening. And we're going to use the same idea as before because these are independent events, which means that whether or not I get red or green from the first bag doesn't affect the probabilities of getting red or green from the second bag. So, which makes total sense really, because whatever happened from a first bag, a totally different bag, would not be affected by it. So what we're going to do then is we're going to say the and will become a multiply. So that's very important. So we've got probability of getting green 1 times probability of getting green 2. So what we do then is we just look at the 2 probabilities that represent those. So it's the 3/5 and the 5/8. So I'm going to just write that here. So it's going to be 3/5 times by 5/8. And I could do that on the calculator, but this one's quite a nice, easy one to simplify. So I can just see that the 5s will cancel there. And that's going to give me 3/8. So the probability of getting a green followed by second green is going to be 3/8. Okay, so we could actually, I'm going to extend this question a little bit. So we could say, well, often we might get asked, a third part to this, we might get asked, what's the probability that they are both the same colour? So what's the probability, I'll just abbreviate that they are both the same colour? So if we think about what that actually means, the way of getting 2 colours the same would be, got to go green, green, and we've already worked that one out, or we could go red, red. So in other words, what we're saying is the probability that they're the same, both the same colour, I can abbreviate it by just using the P, probability both same colour would be that they are either, so it's probability that we say in the both green, and then the magic word here really is or, is what we're looking for, or both red. Now, what we've got here, and this is very important to recognise, we've actually got what's called mutually exclusive events. Now, sounds very complicated, that, but don't be put off by that. All that means is, if two things are mutually exclusive, they can't both happen. So they can't both have happened. Let me just like that. Can't both happen at the same time. So we can see in this case that must be true, because if we've taken two counters from the bag, they can't both be red and at the same time both be green. They're either green or red. So that's what it means to be mutually exclusive. Getting two reds is mutually exclusive to getting two greens, because they can't both happen. It's either two reds or two greens in this case. So in that case, when it's mutually exclusive, the or turns into a plus, and it becomes the probability of both green. I'm just going to write that as green and green, plus the probability of red and red. So in which case, the probability that we've got green and green, we've already worked that one out. We know that. So that one we worked out before, probability green, green, we already worked out, I think it was 3/8 from above, 3/8. 3/8. So we need to then work out probability that we're going to get red and followed by red. So let's have a look at that one. So I'll move the board up again to the tree diagram. So we work out probability that we've got two reds. Quite useful sometimes to just write them at the end of each line. So we can see probability of going red and then red would mean to follow this route. Start here for the first bag, go down there, and then go up this route. The probability of getting a red followed by a red, well, that's red and red. And so that becomes multiplication. So we take the 2/5 there and we multiply it by the 3/8. So we've got 2/5 times by 3/8. So if we just tidy that up a bit, so the 1 and the 8 will simplify to being 1 and 4, or the 2 and the 8 cancel to be 1 and 4. That becomes 3/20. And previously, so I might want to write it like this, probability of getting green and green, I think we got, have a look what we did get for that one. I think we got 3/8, yeah. 3/5 times by 5/8 is 3/8. So what we then need to do is add these together. So I'm going to just take this back down here. So 3/20 is what we've got for that one. 3/20. So we've got to add them together. So probability of green and green plus the probability of red and red. In other words, the probability of getting both green or both red would be those two probabilities added. So we'll just go 3/8 plus the 3/20. There we go. And I'm just going to do that on the calculator, just so we don't get bogged down in looking at adding fractions. So we could just do that using the fraction button. So we've got 3/8, and then plus fraction button again, 3/20. And the nice thing about using this as well, if we can use the fraction buttons, is it should simplify it to its simplest form. So we get 21 over 40. That's our probability of getting either 2 reds or 2 greens. In other words, that's the probability that they're both the same colour. So I hope you found that helpful, and if you have, I hope you consider subscribing to our channel so you get notified to watch more of our live streams and see more of our videos. So thanks very much for watching.